Good morning, good afternoon, everyone. Welcome to today's webinar, the Ultrasound Implementation Essentials. My name is Ahmed Mu'taz. I'm very pleased to have you all with us today. In this session, we will cover the fundamentals of the ultrasound technology, its applications, and how it can truly transform your maintenance and reliability programs. I'm joined today with my colleagues, Mohannad Mansour, who will be sharing his expertise on the practical ultrasound and field implementation, and Saeed Hassan, who will take us also through the software and the hardware and the data collection part. So we hope this webinar will be informative to all of you, and please feel free to share your questions. If you have any questions, please feel free to share it in the chat box, and we will make sure to answer all the questions. So let me first give you a quick brief about US Systems. So in US Systems, we are a US-based company, started in 1973. We have almost 51 or 52 years manufacturing the ultrasound tools. We are available ourselves in the region in order to support you. We are working directly with most of our customers in order to make sure of the best aftermarket support and training as well. So in US Systems, we are not only manufacturing the ultrasound tools, we are in the ultrasound equipment, we also have a continuous software development to meet our customers' expectations. We have our training and support on board and the certification training CAT 1, CAT 2, and 3 as per the ISO 18436-8. And also we offer the on-site and online implementation programs in order to take you to the best or the next level of implementation and to kick off your ultrasound program in your plant. We have also the online solutions available in our tool belt. And today we will be covering the main essentials of the implementation of the ultrasound programs and all our tools. I just don't want to forget that all our equipment and all our instruments have 5 years warranty from the day you start using it. So I'll give the mic to my colleague Mohannad Mansour, who will take you and will start to share his expertise on the practical ultrasound inspection, and then Saeed will follow him.
Thank you, Ahmed, for the introduction. So throughout the event today, we will discuss the reasons why we should use the ultrasound technology in our plants. Then we will be taking you through the journey of a successful ultrasound program, how to implement it, what are the key points to consider, and so on. Moreover, we will discuss in details how to build a database for your equipment and how to acquire measurements correctly to log it as a baseline for monitoring and trending. Then we will present some case studies from different industries to explain how the defects can reflect on the measurements and what are the patterns to expect in the time waveform spectrum. And finally, we will update you with some of our latest solutions and products that can help protecting your equipment, optimizing its efficiency. So why ultrasound? The first answer that comes to my mind for this question is that because it's so simple. You can listen to your equipment as if you gave it a sound to tell you what's going on inside. You can listen to friction levels, identify if there is contamination or bearing defects, and can easily distinguish the healthy bearings from defective bearings, for example. The ultrasound technology is also cost effective. For example, leak detection is a very easy application that can save you a lot of money as it optimizes performance, efficiency, spare parts for the compressors, and so on. So money-wise, this will be very helpful for your facility. And also, ultrasound is a very versatile technology. You can use it in many types of applications and many types of equipment. So it's interesting that you can find the same ultrasound instrument model used by rotating equipment team, static team, electrical team, sustainability, and so on. So we call it versatile technology as it can be used for bearing or mechanical inspection, electrical inspection, valves and steam traps, leak detection, and any other application where turbulence and friction levels can be a measure of system performance. So in order to start an effective ultrasound program, there must be 3 essential components. First, your ultrasound instrument. The model of the instrument will depend on your application. If you have UP15000, you can do any application. You can have the Grease Caddy 401 for lubrication purposes, and so on. Second, the software offered by US Systems for trending and analysis. This is where you can build your equipment database and log measurements to it, trend your decibel levels, analyze your sound measurements, and last but of course not least, the trained personnel that will lead and implement that program. Because you can have the highest instrument models and the up-to-date software, but without trained personnel, you will not be able to implement a successful ultrasound program or an effective ultrasound program. So if you have any issues within these three essential components, you can contact us for support, whether you need to decide which is the most effective model for your application, or you need support with the software installation, or you need even a tailored training for your industry. We are more than happy to assist you in that. Okay, so now if you have all the fundamentals in place, how to initiate the ultrasound program? To start establishing the program, we can follow a series of clear steps. First, manpower assessment, then equipment selection, walkthrough, building database, establishing baseline, and finally trending. We will be discussing these steps in more details now. Our first step is to assess our manpower. We need to know how many qualified, trained, and certified people we have available to dedicate to this program. This would help us ensure we have the right team to achieve optimal program efficiency. This assessment is also essential for deciding how much equipment we can include in the program. For example, if we have 2 qualified personnel, we cannot effectively monitor 500 pieces of equipment monthly. Doing so would definitely lead to a drop in quality, or even if our team is well trained. Now that we know how many trained team members we have, we can move on to equipment selection. This information helps us to determine how much equipment to include in our ultrasound program. Criticality will be the key factor in our choices. We will select highest critical equipment and where ultrasound offers the best value. For example, in a mechanical inspection program, we would focus on anti-friction bearings, slow-speed machines, equipment with lubrication problems, or where we aim for lubrication excellence, pumps and gearboxes, and so on. This approach ensures we use the best technology for each piece of equipment, making our overall maintenance strategy highly effective. The next step is the walkthrough, which is very important for both safety and planning. First, we identify any safety issues that we might encounter while taking the measurements. This includes things like hard-to-reach points, hot surfaces, or uncovered rotating parts, and so on. During the walkthrough, we also decide how many measurement points we will take on each equipment and pinpoint the best measuring point for each one. And finally, we plan the most efficient route for collecting the data based on the equipment's location. Now we are ready to build our database using the DMS software. We will use all the notes we took during our walkthrough. We will create each machine in the software one by one in the correct order. For each machine, we will add the available measuring points, and any specific comments about a point can be written in the comments section in the software. This organized database structure will help us keep track of everything and make analysis much more easier. Once the database is established, we will be ready to collect our baseline measurements. This phase typically is the most time-consuming phase, as we capture images for each measuring point, adjust the sensitivity and tune the frequency for each point, record sound files, analyze the measurements, and learn more about the unique ultrasound patterns for each piece of equipment. Although this phase requires a significant time investment, this phase is the most important. It builds the essential foundation for all future measurements and analysis. Now that we have the baseline measurements logged, we can trend the selected equipment over time. This allows us to observe any changes in the decibel levels, time waveform and spectrum, or the sound quality, all of which reflect a change in the equipment's condition. For example, in most common rotating equipment, an 8 decibel change usually indicates a lubrication problem. If we see a 16 decibel change from the baseline, we will analyze the time waveform to understand the type of defect causing this increase. Based on that, we can monitor more closely or more frequently until we decide to take an action. A 35 decibel change means immediate action is required. We can analyze the measurements to know more about the nature of the problem, but most likely there will be severe damage. So now my colleague Saeed will be presenting the database creation and will give you more insights into the DMS.
Okay, thank you, Muhammad. Thank you, Ahmad, for this. Good afternoon, everyone. My name is Saeed Hassan, and today I will walk through how to build an accurate and scalable database in DMS, a critical step for improving reliability and making ultrasound inspection program more efficient, impactful, and reliable. So why DMS matter? DMS is more than just a storage system. It is a brain of our ultrasound inspection program. When built it properly, it enables an accurate diagnostics, reliable trending, and faster decision making. But if the database, like the right side here, is not structured well, we get an accurate data, weak insights, and show how to do it right from the start. A well-structured database is the backbone of any predictive maintenance program. It minimizes human error, accelerates the inspection process, and ensure that alarms and condition trends are reliable. When you take the time to build your database from the beginning, you save countless hours later on, whether it's during analysis, troubleshooting, or even reporting. Now let's walk through how to create a demo database. So we will begin by navigate to the file menu, selecting it, and then right click on the file menu. We will select new plant. In the new plant, okay, selecting new plant. In the new plant, we'll type the name that you want to create. You can set up multiple plants within the same database if needed. In each plant, we organized our assets by areas. To create an area, select the bearing first, then the left menu of the bearing, then right click and choose new group by wizard. In the new group by wizard form, it will pop up a new window. You will be prompted to name the area. Let's call it here area 1. As an example, next you will choose a descriptor format which defines the character limit for the machine and measurement point names. 8/8 format allow 8 character for the machine name and 8 for the measurement point. 13/3, which will commonly use, gives 13 character for the machine name and 3 points only for the measurement point. Now let's create a machine. I will name this machine machine 1. Then we'll define its associated measurement points like motor non-drive, motor drive end, motor terminal box, and pump drive end, pump non-drive. If we have similar machine, we can simply copy and paste this machine. The one we just created, we can just copy, then paste it. However, you will notice a red error if the machine name is duplicated. In that case, just rename it. For example, I will make it machine 2. A good or professional tip, one of the best practice is to prepare your asset structure in Excel sheet first. Include every machine along with its associated measurement points. This allows for easier edit and validation. Once finalized, you can copy this list directly from the Excel, open the group by wizard again, and just paste it, and it will be generated immediately. So now we create the route, we create the areas, we create the plans. Let's upload this data to the instrument itself. So if we want to transfer the route to the UB15000, we have two types. We have the latest version, UB15000, in the blue color. To begin, we need to go to the communication window and select configure probe. When we select configure probe, a new window, a probe manager window will appear. Click new, and another window will open, and we will select from it. It's not here. Yes, this one. Okay, and we select next, then automatic probe detection. Then next, a new window will appear here. It will tell you the system will instantly display a list of available instruments such as UB15000, UB10000, UB401, and UB15000B. If you are using the latest version of the UB15000, the blue one, select UB15000B, then press finish. Now we connect the instrument to the DMS. Okay, by the SD card. Okay, we can connect by the SD card. In our case, since we are using the latest version of the UB 15000, we selected UB 15000B. Next, we will open the communication again, and we will select group for synchronization. When we select group for synchronization, a new window will open. Here is the great news. If you are using the latest UB 15000, you can upload multiple plans, multiple routes, even multiple application. We can add more than one plant, we can add more than one area, we can add more than one application on the same time. Once your instrument is loaded with the required routes, you are ready to take the measurement. After completing the measurement, you want to transfer the data back from the UB 15000 to the DMS. You will connect the SD card, and again you will go to communication. Then you will select synchronize groups on the probe. It will automatically download all plant data. If the data will be imported and automatically stored in the correct location within your database, accurately aligned with the asset structure you created earlier. If we are using the old version or the last version of the UB 15000, the black color, it is similar to the previous one. We will start with communication and selecting configure probe, and we will make a new probe, a new configuration, select next, then automatic probe detection, and here we will choose UB 15000 only, not UB 15000B, but UB 15000. Please note, with the last version of UB 15000, you can upload only one area and one application at a time. While this limits flexibility of the workflow, you can use multiple SD cards for if you are to the site and wanted to inspect two areas, you can have two SD cards with you. Now we can choose the area in the DMS, locate the area you wanted to measure, right click on this area and select send group to probe. This will transfer selected area to your instrument. And when you finish when you finish taking the measurement, again install the SD card in your PC and go for communication test connection. Then right click the area name and select retrieve group from the probe. After you finish collecting the data and you already transfer the data again for to the DMS into the DMS, we can now view and analyze in detail. When we select a specific measurement, a window will appear with several tabs included record information, images, history, chart. Let's focus first in the record information. On the left hand side here in the record information, we will find a valuable information like the decibel value, the sensitivity, bearing number, RPM, notes or comment by the inspector here. And on the bottom right here, this is the grease caddy information, like blend stroke, actual stroke applied, type of grease. So available information will be for each record here. This view gives you a comprehensive overview of the asset condition. By default, DMS treats the first measurement as a baseline. However, you can update this baseline if like a new bearing has been installed, the application has been performed, and the dB value significantly decreased. So we can change it, the baseline later. When you are confident that the reading reflects the healthy reference condition, you can proceed to set the alarm level. How we can set the alarm level? Click on the alarm tab, and here you can find high alarm and low alarm, and this is the baseline measurement. In this example, the decibel value is 10 decibel. To set the low alarm level, it is recommended to have 8 decibel above the baseline measurement. So the low alarm will be 8 decibel, and the high alarm will be 16 decibel above the baseline. Then we will click on update alarm using the delta, and automatically all the measurement will be updated immediately. All the measurement will be updated. So reading above the low alarm limit will be highlighted in the yellow color, and reading above the high alarm limit will be highlighted by the red color. Another powerful tool of the DMS is the chart. The chart on the DMS will show x-axis and y-axis. X-axis represents the ultrasound measurements, and y-axis is the amplitude of this measurement. And here we have the baseline measurement, the green color, and the orange color or yellow color here is the low alarm level, and the red color is the high alarm level. So in our case, for example, the dB level gradually increased over time and crossed the low alarm limit. A greasing action was performed here, and then the dB value dropped back near to the baseline. And we take routine measurement for this equipment. So after some times we find it going up, it exceeds the first limit. But here we didn't take a greasing action, so the friction keep going up until this led to increased friction and developing fault until eventually exceeds the high alarm level. This chart is an excellent visualization tool for tracking asset behavior and identifying when action is or isn't being taken at the right time.
So we'll complete the software or the DMS part here. So as Said was saying, we can have for each measurement location, we can have picture information of the measuring point, just to ensure that the measuring point is correct and make sure it's repeatable each time we take the measurements. We can put or mount the sensor on the same measuring point. And also you can notice we can have two types of images automatically saved in the measuring point. When we take the image from the instrument, we can have two types of image. One is a high resolution image to show the details of the picture itself, and the other one is a little bit lower resolution but with measurement information. Measurement information like the point name, the sensitivity, decibel reading, frequency, record number, date, and so on. And this is mainly used in reporting. Also, we can take like screenshots from the time waveform and we can add it to the measuring point, just for reference and for the historical trending of the measuring point. Additionally, we can also create history tables, just to keep track also of the decibel levels along with time, and compare it to the baseline, low alarm, high alarm, and so on. So now we will discuss, we can use also the DMS software to check the measured time waveform for analysis. We can open the other software, the Spectralyzer software, which is used for the analysis part. We can open it from this icon we have here in the record information. We can open the wave file, and the Spectralyzer window will be automatically opened, which will allow us to do the analysis of the time waveform. Another important feature in the DMS software is the import-export database. We usually make this exporting or database exporting if you want to keep a backup of the database. We can export the database to a location where it can be used as a backup, or if we want to transfer the database into another computer or into another software installed on another computer, we can check the export database. Also on the other computer or on the other software, we will click on the import database there to import all the measurements, all the measuring points, all the records, all the alarms, and everything. Also, it's one important point in the DMS software is the dashboards. The dashboards, you can select areas and it will show you how many points are having low alarm, how many points are having the high alarm, how many points in the area are in good condition, and so on. Also, one, let me say, abandoned feature of the DMS software is that whenever you're having any alarms for any points, whenever you download it, if you downloaded the data, for example, after an inspection, you can send a notification through email. So you can put here the first name and last name of the notified person, and you can also you can provide his email address, his cell phone number, but if this cell phone number is not available in the Middle East, we can only send notifications via email anytime when the data is retrieved to the software. So now we will discuss the reporting. The reporting in the DMS software is very easy, especially the 4-picture report, which is the most used type of report in the DMS. For the 4-picture report, we can choose, for example, one equipment, and we can include images from the records of this equipment. We can include, for example, the screenshots we took from the Spectralyzer software and we added it to the measurement point. We can include images of the measurement location, and we can include the image with the measurement data, like the decibel reading, sensitivity, frequency, and so on. And also we can include the wave files, the recorded wave files to the report, and it's like just selecting what you want to include in the report, and you click OK, and the report is automatically generated like this way. So the report will include the location. Yes, Said?
Sorry for this. I have a technical issue happened to my laptop. So
Okay, please
yes,
continue.
please. So okay. So in the technical report that we can get from the DMS, we can get the photos with the details, the time waveform that we make analysis in the Spectralyzer. Also, we can add our analysis in the comment and the recommended actions here in the recommendation port, and also to have the sound file. So when you share the report, the receiver from the maintenance team, he also able to listen to the sound of the machine, so he can feel the real situation of the machine. To capture reliable baseline data, we need UB15000, DMS database management software, and of course Spectralyzer to start this measurements or capturing the data. Why baseline DMS matters? It is the foundation of any effective CVM program, enables an early stage for fault detection, ensure constant trending and analysis, used for comparison over time, and critical for decision making. So during the baseline measurement, what things shall we consider? We shall consider to select the correct frequency. The recommended frequency for most rotating equipment is 30 kilohertz, and for slow speed machines, you may reduce it to 25 kilohertz to improve sound clarity and better capture low energy acoustic signals. And also, one tool is very important. Important is adjust sensitivity. Sensitivity setting play a major role in ensuring an accurate reading. Proper adjustment help filter out competing ultrasound and allow an instrument to focus directly on the measurement point. Also, please remember that use the trigger always to get a live decibel value. To view a real-time decibel reading, you must press and hold the trigger on the instrument. If the trigger is not engaged, the screen will be displayed and freeze on the last recorded value, rather than updating live. Following these steps will help you to collect reliable baseline data, which is essential for accurate monitoring and early fault detection. Okay, can go for next. So this is about the instrument, the consideration about the UB15000 type. We have talked about the instrument setup. Now let's discuss the location of the measurement point, which itself equally important for accuracy and safety. The best practice for capturing baseline measurement is to use a direct contact point the surface should be clean, accessible, and safe to approach. Solid connection ensures accurate reading and reduces signal loss. However, when the point is not safely accessible due to guarding height or moving parts, we highly recommend using the remote access sensors, which is you can install these RAS sensors and we can collect the data far away from this point with a safe approach. RAS sensor is permanently installed on the instrument point and connected to a switch box. This switch box will allow you to collect data from a safe distance and accessible multiple hard points to reach from one central location. Complete inspection faster and with improved safety. This solution is ideal for hazard areas or risk environments and ensure your baseline measurement remain constant and reliable without compromising safety. Also, when capturing ultrasound data, selecting the optimal measurement location is key to obtaining accurate and repeatable results. The ideal measurement point is typically close to the grazing nipple, and also we can get measurement on bearing housing and provide good signal transmission. However, if the bearing is accessible, you can also measure directly on the bearing body, and here is the recommended process. Adjust the sensitivity of your instrument. Take reading in the three directional, vertical, horizontal, and axial. Listen carefully and absorb the reading. The locations that give you the clearest sound and highest decibel value is typically the most responsible and reliable point for data collection. Once identified, you can mark this location, or it is better or greater accuracy and repeatability to install the UTB. The UTB is a test point. We can install this UTB. It will give us more constant reading, improved reliability for the trending data. Establishing and standardizing your test point is a small investment, leads to much better diagnostics and long-term reliability. Finally, when we're dealing with similar equipment, we can use the compare method. What measurement to get? We shall record the decibel value, sound file, time waveform, and spectrum, photo of the measurement location, as condition like load, temperature, RPM, note or observation about the condition of the equipment. This is very important to note while we collect the baseline measurement. We can dealing with similar. If we are dealing with similar equipment, one helpful tool in the DMS is to use the compare method. If you have multiple identical machine, like this example, we have 6 motors, 1, 2, 3, and the other side 1, 2, 3. If we have a similar running condition, it shall be having the same baseline. Like for example, 5 out of 6 here of these motors have decibel value, 3 decibel value, and only one motor have 12 decibel value. So in this case, we should not consider the 12 decibel value reading as a valid baseline. It may indicate an early stage of fault or lubrication issue or faults. So we cannot consider this as a baseline for this motor. So which of the machine is truly reflect a healthy condition? In the next slide, Mohammed, we have 2 cases, please. We have 2 cases, the left side and the right side. See this motor and see the time waveform. Can we play the sound file? Okay, in this case, we have smooth time waveform, we have normal rushing sound. So what do you think? The other example, so we have 2 cases. The first case, we have normal rushing sound, rush sound, and smooth time waveform. We don't have any impacts, so we can consider both of them is we are measuring for the first time. The first motor we can consider a baseline measurement, and the other motor it also the first time to measure, but we can hear the clicking sound, and also in the time waveform we can see impact sounds. So I know this equipment have a fault, so I cannot consider this measurement as a baseline measurement. Finally, this is a recommended action before you leave the site is to open the root feature in the UB15000 to check all the measurement. A green check mark indicates the measurement was successfully taken and saved. A red cross mark appears if a reading was missed or not saved properly. The visual cue provides a quick overview of route compilation and help you ensure no points are left behind you before you leave the site. So we take the baseline measurement. So what is next after we take the measurements? Once we have established an accurate baseline, you have laid the foundation for reliable condition trending, engaging predictive maintenance, timely intervention, and extended equipment life. So if, for example, if we have here in our case 10 decibel value is our baseline, so if we increase 8 decibel above the baseline, it will be application issue. If it is increased above 16 decibel above the baseline, it will be a damage or visual fault in the FFT. And also, if it is increased more than 35 decibel, maybe extreme damage will happen. So thank you. This concludes my session of this webinar. Now I will hand it over to my colleague Muhannad, who will continue with the next segment.
Okay, thank you, Said, so much. And now let's explore some real-world case studies from different industries. The first case study focuses on detecting bearing defects with ultrasound in an industrial blower. So ultrasound was used to monitor the machine bearings monthly, and during a recent inspection, the inspector noticed an unusual sound generated from the blower drive end bearing. Let's hear this sound. So after analyzing the time waveform, impacts at the inner race defect frequency were found modulated with the blower's running speed. And every one complete revolution of the blower shaft, the impact is amplified, as you can see here in the time waveform. This actually corresponds to the inner race defect entering the load zone of the bearing. That's why there is an amplification of the impact every one cycle. So it was recommended in this case to replace the blower bearings, and upon inspection, a clear defect was found in the inner race as it shows in this picture. And after the bearing replacement, another measurement was recorded, and it showed a smooth rushing sound compared to the previous measurements of the defective bearing. The second case study focuses on detecting mechanical issues within a hot oil pump. So high vibrations were observed on the machine bearings during the routine inspection. The vibration spectrum was showing 1x and harmonics, and the time waveform was showing impacts at 1x as well. This pattern was observed on both motor drive end and pump drive end bearings with the same amplitudes, and the plant needed to take an action as there was a few hours shutdown only. The ultrasound technology was used to pinpoint the source of the impacting sound, and both motor drive end and pump drive end bearings were showing the same 1x impacts also as the vibration measurements. So that was the sound recorded from the motor drive end bearing. Now we will listen to the sound recorded from the pump drive end bearing. So in this case, the airborne sensor was used to determine whether the impacting source is internal within the bearings or it's external from the bearing. And it was found that the impacts are generated from the coupling, as this sound was recorded from it. So as an immediate recommendation was given to replace the coupling, and as shown here in the picture, the coupling rubber found totally worn out. So now, as discussed, we will give you an update of the latest products and online systems. The first new update from UE Systems is the new UP15000, which is more compact, lighter, and faster than the old model. It also includes data transfer via Wi-Fi and it supports multi-groups handling. The latest online solution is the on-track wireless condition-based lubrication system. It consists of a wireless integrated sensor, wireless integrated ultrasound, vibration and temperature sensor, a wireless single-point lubricator, and a gateway that connects the lubricator and sensor to the software or the platform. So this system works by measuring the dB levels from the ultrasound sensor, and whenever there is an increase in the friction levels in the bearing, it automatically sends an order to the lubricator to inject grease and give a feedback of the whole lubrication operation or the lubrication process. There are multiple mounting solutions for the on-track so that it can be mounted in hard-to-reach or confined space areas by using the remote mounting kits shown in this picture. This slide shows how the monitoring platform looks like. Here you can view the measured ultrasound, vibration, and temperature data for each bearing displayed directly on a picture of the machine. The platform also provides vibration indicators such as misalignment, imbalance, and more, and you will see decibel trends that are always compared against baseline measurements. Plus, you get complete feedback of the lubrication process, including the decibel readings for both before and after the lubrication. So that's all from our side today. Thank you all for joining. It's been a pleasure sharing this session with you, and we look forward to connecting with you again soon. Thank you.